So why exactly did your cake sink? Look, we've all been there, right? You put what you honestly thought was a culinary masterpiece into the oven, only to pull out this dense, frustrating crater of a dessert that looks, well, more like a modern art project than a cake. Most people just shrug, blame bad luck, or assume they just aren't natural bakers. But what if I told you that luck has absolutely nothing to do with it? And that brings us to our foundational rule for today. Baking isn't magic. It is chemistry. Professional baking relies entirely on precise chemical reactions and mathematical formulas. Seriously, when you understand the underlying science, you control the outcome every single time. Welcome to This Explainer. Today, we're diving into a fast-paced culinary masterclass designed specifically to help you absolutely crush the TESDA bread and pastry production NCII assessment. We're going to decode the science, the math, and the exact techniques those assessors are looking for, basically transforming you from a hopeful home baker into a fully competent professional. Here's our roadmap for today. First, the science of ingredients. Second, mastering mixing methods. Third, the bread-making journey. Fourth, troubleshooting baking disasters. Fifth, bakery math and safety. And finally, the formula for success. Let's jump in. All right, Section 1, the science of ingredients. We're looking at what these ingredients actually do chemically once they hit the mixing bowl. Understanding your raw materials is your absolute foundation. So let's talk about an incredibly important concept, gluten. Now, gluten isn't just some health food buzzword. It is literally the microscopic scaffolding of all your baked goods. When two specific proteins found in wheat flour, glutenin and gliadin, combine with water and get physically agitated through mixing or kneading, they form an elastic network. This viscoelastic web is what traps carbon dioxide gas during fermentation. That's what gives your bread its structure, its chew, and its volume. Without gluten, your bread would basically be a flat brick. And that's why protein percentages completely dictate your flour choices. Bread flour sits high at around 12 to 14% protein. That means it's going to develop a ton of strong gluten, which is perfect for a chewy pain de sal or a French loaf. But think about cake flour. At just 6 to 8% protein, it produces very little gluten, which is exactly why it gives you that soft, tender, delicate crumb in your butter cakes. Choosing the wrong flour means you're setting off the wrong chemical reaction from the very start. This same need for precision absolutely applies to your leavening agents, the ingredients that create the gas to make your bake rise. People mix these up all the time. Baking soda is pure sodium bicarbonate, so it requires moisture and an acidic ingredient like buttermilk or cocoa to activate and produce carbon dioxide. Baking powder, on the other hand, is a complete leavener. It already contains a dry acid in the mix. It just needs moisture and the heat of your oven to give your cakes that beautiful lift. Precision here is non-negotiable. Moving right along to Section 2, master the mixing methods. Basically, how to combine your ingredients correctly. Now, assessors love to test you on this. How you combine your ingredients is just as important as what you actually put in the bowl. Take the creaming method, which you'd use for butter cakes. You have to vigorously beat the fat and sugar together for 5 to 7 minutes until it's super pale and fluffy. You are literally cutting microscopic air pockets into the fat using the sugar crystals. But contrast that with the muffin method. Here, you mix your wet and dry ingredients separately, combine them, and fold just until moistened. Honestly, if it looks lumpy, that is perfect. If you overmix muffin batter, you'll overdevelop the gluten and cause these disastrous, massive holes inside your bake. It's a massive defect that professional bakers call tunneling. Up next, Section 3, the bread-making journey, taking it from raw dough all the way to the finished product. Look, making bread commercially isn't some casual afternoon activity. It is a strict, 9-step scientific process. Let's start with the first 4 steps. You kick things off by accurately scaling your ingredients by weight, mixing them, and then kneading. Now pay attention here, because during step 3, kneading, the assessors will be watching you like a hawk for the window pane test. This is arguably the #1 oral question they ask. You must be able to stretch a small piece of dough gently between your fingers. If the gluten is properly developed, it's going to stretch thin enough to let light pass through it, literally like a window pane without tearing. Once you nail that test, the dough moves to step 4, bulk fermentation, where the yeast gets to work. Continuing the journey, you punch the dough to expel the excess gas, shape it tightly to create surface tension, and let it undergo its final proof. Step 8 is baking.
where oven spring happens. That's that rapid final burst of expansion in the first 10 minutes before the intense heat finally kills off the yeast. And finally, step 9, cooling. Okay, I know it is so tempting, but never, ever cut bread while it's hot. The internal starch structure is still gelatinizing and setting using the residual heat. Actually, scratch that. Just don't even think about slicing it early, because if you do, you'll completely destroy the crumb, leaving you with a gummy, dense mess.
All right, Section 4, Troubleshooting Baking Disasters. We're connecting all that chemistry to real-world failures. So, assessors will often show you a defective product and ask you to identify the scientific cause. Put yourself in this scenario. Imagine pulling a beautifully crimped pie crust out of the oven. It looks amazing, but when you go to slice it, it is rock solid. So you have to ask, why is your pie crust tough and hard? Well, think about the 4 main causes for this, and notice how every single one is a breakdown in our core chemistry rules. A tough crust happens because maybe you overmixed the dough, which overdeveloped the gluten. Or you added way too much water, which hydrated too much of that gluten. Maybe your fat just wasn't cold enough. Remember, cold fat creates steam pockets that give you that flakiness, while warm fat just blends right in and makes everything dense. Or worst of all, you used high-protein bread flour instead of low-protein pastry flour. See how it all just connects right back to the science? Which brings us to Section 5, Bakery Math and Safety. This is what gives you that professional edge. To pass the NCSU assessment, your math has to be just as sharp as your chef's knife. Let's dive into a vital tool, baker's percentage. This is quite literally the universal language of professional bakers. Instead of relying on rigid, inconsistent cups or tablespoons, every single ingredient in a recipe is expressed as a percentage relative to the weight of the flour. This brilliant little trick allows you to scale a recipe up to feed an army or down to feed just 2 people with absolute mathematical perfection. So the single most crucial point to lock into your memory right now is 100%. In baker's percentage, the total flour weight is always 100%. It's your anchor. For example, if your recipe calls for 500 grams of flour and 275 grams of water, the water is simply 55%. This system makes identifying recipe imbalances practically instantaneous. Now, just like our math, our safety standards have to be totally flawless. We achieve this using HACCP, Hazard Analysis and Critical Control Points. Listen, food safety isn't about crossing your fingers and hoping for the best. It's a very active, documented system of prevention. You have to analyze hazards, like biological bacteria or maybe chemical cleaners, and establish critical control points, like mandatory baking temperatures to eliminate those risks way before a customer ever takes a bite. And that brings us to the most critical safety limit of all, the temperature danger zone. We're talking between 5 degrees and 60 degrees Celsius. In this specific zone, dangerous bacteria multiply exponentially, potentially doubling every 20 minutes. Your ingredients and any finished products with dairy or eggs absolutely cannot sit in this zone for more than 2 hours. The rule is simple. Keep hot food hot and cold food cold, period. Finally, Section 6, the formula for success. Let's bring this whole shebang together. We've covered the microscopic chemistry, the physical techniques, the math, and the safety protocols. And this right here is the literal formula the assessors are going to use to evaluate you. Food safety plus correct procedures plus product quality plus professional presentation equals competent. Passing the TESDA NCI is not some subjective guessing game. It is a predictable, calculated result of respecting the science and executing the standards. You now possess the scientific roadmap to conquer every single loaf of bread, every pastry, and every cake you attempt. So, the only question left to ask yourself is, are you ready to step into the kitchen, command your ingredients, and turn that chemistry into absolute competency? Go get baking, and I'll see you in the next explainer.